Let me start with something very important. In engineering, failure don't always happen because of big mistakes. Most of the time, failure happen because of small decisions that people underestimate. And one of the most underestimated component is a screw. Now just think about this. You design a machine, you perform all the calculations, you select a proper material. Everything looks perfect, but after some time, vibration starts, joint begin to loosen, noise increases, and eventually failure happens. And when you investigate the root cause, it comes down to one simple mistake: wrong screw selection. Now, look at this image very carefully. On the left side, you can clearly see corrosion, rust, surface damage. Now, as an engineer, what does this indicate? Corrosion has reduced the effective diameter, which directly reduces load carrying capacity. Surface pitting creates the stress concentration points, and under cyclic loading, fatigue failure becomes faster. So, this screw is already in failed condition even before complete breakage. Now compare it with the right side: clean surface, proper threads, no corrosion, which means correct material selection, proper environmental consideration, and controlled design. This screw will perform reliably. So, both screw may look similar to a normal person, but for an engineer, they represent two completely different components. Welcome to Abhi Mechanical Design, where we don't just look at the components, we understand their behavior in real condition. Think, design, build. Now, let's go deeper into the fundamentals. What exactly does a screw do? Most people say it just holds part together, but that's not technically correct. In reality, a screw is a force generating mechanical component. When you apply torque at the head, the thread convert rotational motion into the axial movement, and because of that, a clamping force is generated. This clamping force is called preload, and this preload is extremely critical because it is this force that keeps two components tightly pressed together, prevent relative motion, resist external loads, and maintain structural stability. If preload is insufficient, components will slip, vibration will increase, and fatigue failure may start. If preload is too high, threads may strip or the screw may yield. So, even tightening a screw is an engineering decision. And if you want to understand preload in detail, check out the dedicated video on this channel. The link is in description. Now, let's understand the parts of a screw. Head, where torque is applied. Shank, which carries a load. Thread, which creates a mechanical grip. Tip, which helps in penetration. Every element is designed for the purpose. Nothing is random in engineering design. Now let's connect this to the real world application. In automotive system, screws are used in engine assemblies, chassis connection, and interiors. In aerospace, structural joints, panels, instrumentation. In construction, steel frameworks, and the load bearing connections. In electronics, PCB mounting and enclosures. In machinery, gearbox, pumps, rotating elements. So essentially, screws are everywhere, and if the screw fails, the entire system is at risk. Now, think like a design engineer. Why are screws so widely used? Because they are easy to assemble, easy to disassemble, reusable. They provide strong clamping force. They are economical and they allows flexibility in design. That's why screw dominates the mechanical systems. But now comes with the critical part. Their limitations: screw can be loosened due to the vibration. This is very common in engines and rotating system. Threads create stress concentration, which becomes the starting point of a fatigue cracks. Drilling holes reduces component strength. In high temperature or corrosive environment, failure can accelerate rapidly. So, we cannot blindly use screws. We must design with understanding. For example, in automotive engines, bolts are tightened using torque plus angle method to ensure correct preload under dynamic condition. In aerospace, locking mechanism like a safety wire or lock nuts are used to prevent loosening under vibration. This is the real engineering practice, not a theory. If you are understanding this level of details, hit a like button and subscribe to Abhi Mechanical Design, because here we convert theory into real engineering thinking. Now comes with the most important part: screw selection. First, based on application, machine screws are used in precision assemblies. Self-tapping screws, they create their own threads used in sheet metal and plastics. Wood screws, deeper thread for better grip. Lag screws, heavy duty application. Set screws, used to lock component like gears on shaft. Sheet metal screws, used for thin sections, so selection depends upon the function. Now, head types. Hex head, used where high torque is required. Pan head, general purpose application. Flat head, used where flush surface is required. For example, in aircraft, surface must be smooth to reduce aerodynamic drag, so flat screws are used. Now, drive types: Phillips, Allen, and Torx. Each is designed to improve torque transfer. Wrong selection leads to slipping and improper tightening. Thread types: coarse threads used in wood for quick grip. Fine threads used in metal for strength and precision. Wrong thread, weak connections. And finally, material selection, the most critical factor. Carbon steel, general purpose application. Stainless steel, corrosion resistance. Alloy steel, high strength application. Aluminum, lightweight structures. Titanium, high performance systems. Brass, electrical appliances. Now think practically: marine environment, stainless steel; engine mounting, alloy steel; aircraft interior, aluminum; electrical system, brass. Same screw, different material, completely different performance. So remember this clearly: there is no best screw, there is only the right screw at the right application. And this is what separates someone who studied engineering from someone who understands engineering. If this gives you a real clarity, like this video, subscribe to Abhi Mechanical Design, and comment on your next topic, because here think, design, and build. Thank you.